Alright, what's up everyone? In this video, we'll be crunching the numbers literally on how to relate the sensory evaluation data with other numerical data such as those from physical-chemical tests or even your demographic data. So let's first define our terms. Remember earlier in the SEM, we mentioned the terms association, correlation, and regression. So the only thing they have in common is ending with the same three letters. But kidding aside, so when we use the word association, it usually refers to a measured relationship between nominal or categorical data, meaning those are the numbers that um, you don't really measure them on even an ordinal scale. So examples of these are, for example, demographics of biological sex, whether you're male or female, or country, your other geographical location like your region or city. Those are examples of things that you can associate. So you can associate the demographics with each other. For example, you're gonna look at distribution of your panelists by geographical region and biological sex. So that's one way of doing it. Or any other categorical data that you have obtained from the actual sensory evaluation. For example, their familiarity with certain food types and so on. Correlation, on the other hand, measures the strength of relationship involving at least ordinal level data. So in this case, you get a number more or less that gives you an idea about how strong the relationship is and whether it is inversely or directly proportional. Lastly, when we have regression, this combines with significant difference testing such as ANOVA, and the result includes predictions of the relationship between the variables. So this is what could be considered as a precursor to data modeling, wherein the predictive models can be used to, well, make predictions about how those variables would play out in relation to each other. So for example, you may want to correlate or regress, let's say, hedonic liking with let's say pH level or acidity levels, tetrable acidity levels, or total soluble solids. So that would be an example of either correlation or regression depending on what method you use. And then we have various coefficients which are used to assess the relationship between variables. These are typically between -1 to 1 or 0 to 1. And of course, the closer to 1, the better, the stronger the relationship. Of course, in sensory evaluation, we don't really expect very high regression coefficients because we are using human subjects. So maybe in your chemistry, you've done some linear regression, calculated R squareds. So those are examples, of course, of using numeric data relationships. And these three are somewhat similar to that. So why do we need to analyze the relationship of our data? Okay, first of all, you want to simply do further data analysis if you had some significant differences in your sensory evaluation data, let's say between two samples of a food product in terms of maybe the hedonic rating or results of a difference test. As you know, for example, a difference test would be inconclusive in terms of what constituted that difference. Therefore, you may want to look at the laboratory results from various physical-chemical tests and see if any relationship could be derived between the significant difference and the increase and or decrease in, let's say, the amount of a certain ingredient or a certain measurable physical chemical parameter rather. Okay, you may also want to see if there's a significant relationship between two or more sets of data, such as in the given examples, the effect of cocoa powder on brown intensity color in powder icing sugar mixtures, or the relationship of the total glucose and fructose concentration as determined through high performance liquid chromatography to the relationship of the perceived sweetness of fruit juice samples. And lastly, you may want to determine the relationship of alcohol drinking status to food preferences. For example, is there a pattern in the category of foods that you could relate to the alcohol drinking status? Like, let's say, an aversion to typically bitter foods, maybe, or perhaps an affiliation to eating oily foods, aka pollutant. Okay, so we could test those, and actually, in those cases, those are not per se sensory or physical chemical data, but data you can collect through the demographic information. That's why I want to emphasize in certain studies, it is very, very important to be very specific about the questions you ask during the collection of your demographic data, because these themselves are part of what you need to analyze during your research. So they're not just there to provide background info about the participant, but rather they are essential information for analyzing data relationships, and therefore are heavily involved in the evoke, measure, analyze, interpret chain. Lastly, you want to be able to infer a cause and relationship between independent and dependent variables. Although correlation, regression, and so on does not necessarily imply causation, you could use these to further validate any possible um, causation between the two. So again, when we say association, you analyze nominal or categorical variables. When we say categorical, so these are nominal variables that have been assigned specific categories so that there is a finite number of categories that will be easier to handle. Okay, such as, for example, biological sex are only two, you're either male or female in that regard. And for example, if it's a region, then there are only less than 20 regions in the Philippines. Or maybe you may want to look at, for example, food choices, and you have predetermined categories for each answer for a given food choice. In terms of sample size, a minimum count of 5 for each category cell is needed for analysis to be possible. So take note that this is not the minimum number of, say, panelists, but rather responses under each category. And you can use either cross-tabulation or contingency tables to um, report your data. So we can also use the Pearson's chi-square test as test for independence, which looks at whether there is independence between the two sets of data or there is an association. Kramer's V also uses coefficient from 0, no association, to 1, maximum association. So we'll look at an example of how to use one of these in the next slide. So say for example, you had survey data examining the possible association between the biological sex and the propensity to eat low-fat foods. Um, and this was derived through the use of a specific question. If given a choice, would you choose low-fat foods over the conventional? So you tabulate the frequency of each category, okay? And in this case, we hypothesize in such a manner. Does gender appear to have an association with a propensity for low-fat foods? Of course, the null hypothesis is that regardless of your gender, or if you insist on being politically correct, biological sex would have no association with the tendency to choose low-fat foods. And the alternative is that two-way, um, there is an association between gender and the tendency to choose low-fat food. So either mas pipiliin na biologically male ang low-fat or mas pipiliin ng biologically female. So again, you tabulate the information, the frequency for each of the combinations. So for example, here, males preferring low-fat food, males not preferring low-fat food, females preferring low-fat food, and females not preferring low-fat food. So as you can see here, the chi-square test compares the observed versus expected frequencies as usual. Again, the expected frequency is typically, in this case, 50-50. You'd expect half of either genders and to answer yes or no. Okay, so you tabulate that and input the observed versus expected in the chi-square equation, and you would get, of course, again, that critical value. All right, and of course, you want to compare this with the tabular value based on the degrees of freedom that we have. So given a typical alpha of 0.05, and again, our degrees of freedom is only 1 based on the equation and the fact that there are only two choices. Okay, so we get the tabular value, which is 3.841, and the calculated value is higher than this one. Therefore, we accept the alternative hypothesis. However, this test only tells us on whether or not there is an association and not the strength of association. So to measure the strength of association, we use, in this case, Kramer's V, using a simple equation, getting the obtained chi-square value, getting the square root of that over the number of panelists and your k minus 1. So we get a value here. It's between 0 and 1, or negative 1 and 1, depending on the coefficient you're using. And in this case, so if it's 0.225, then that would mean more or less a weak correlation. Okay, so there is a significant correlation, but it is not that strong, meaning to say it's not a good predictor of the association na kapag lalaki ka, automatic mas ayaw mo na ng low fat food or vice versa.